there, children. Today we are going to work with solving logs. So this first problem here, what we are going to do is I am going to make the bases the same. How, you may ask? Well, I see that I have something equaling something else. If I'm able to make them have the same base, then I can definitely set the exponents equal to one another. Luckily for us here, I know that 36 is 6 squared, and that 216 is 6 to the third. Now, the trick here is I have a power to a power at this point. So I multiply these exponents, getting 6 to the 9x minus 9. Now, over here, clearly these are not on the same level right now, so I can't use that property of same base exponents being equal. However, I'm allowed to flip this fraction and make the exponent negative. Now, usually we're not allowed to have negative exponents, and fairly good stat about that. However, in this case, I'm using it as a means to an end, which means I set them up here because now I have a 6 and a 6. Therefore, I get 9x minus 9 equals negative 2. I'm going to add 9 to both sides, getting a 7, dividing by 9 and giving us 7 over 9. Moving on. Over here again, I can make them have the same base. Now, some of you are probably like, well, wait a minute, couldn't I just do the little loop and turn it into a log? Yes, you could, but you've got to remember this might be an easier and cleaner way to do it. So 8 is 2 to the third. This is 2 to the fifth to the negative n. Now, what I do here is I flip this fraction and make it negative. And make that negative. I also flip this fraction and make it negative. Now here I have a negative times a negative. That gets me a positive. Now, what you've got to realize here then is the following fact. If I have the same base, they're both 2, then I set the exponents equal to each other and solve. Done deal. Moving on up. Now, this problem. Okay, clearly, this 12v is not by itself, so I'm going to divide both sides by 4, because in order to use any of these cool properties, I must have the item with the exponent, the base, isolated by itself. Now, I'm going to leave this as a fraction. The issue becomes here, can I make them have the same base? And the answer is no. I'm sure 12 to some power, I can make 84 over 5 be 12 to some power, because it will be. The problem is I don't exactly know what that is off the top of my head, and I don't expect you to either. So what we're going to do here is use our little loop diagram. Sound effects optional. And we're going to do it that way. Now, it's all about that base, no exponents. So log base 12 of 85 over 4 equals v. Now it's calculator time. You either type this entire thing as one command line in your calculator, or if your calculator does not do that, you go change a base formula. How do I know what to put where? Remember, the base is always going to be the log in the base matter. You could use ln, or you can use log, your choice. It doesn't matter, but you're not allowed to mix and match. Meaning, once I go log, I stay log. Once I go ln, I stay ln. I'm not allowed to go ln of 85 over 4 divided by log of 12. That won't get you a correct answer. And this is going to equal 1.23. Moving on. Now this problem, I've got to divide by 10 first. So I'm going to end up doing that. So I divide by 10. I get 16 n plus 9 equals 72 over 10. Now, what I do is I do my little loop diagram again, because now I have the item with the base and the exponent by itself like I want. Now, I know what you're thinking, but it's an n plus 9 in the exponent. You're right, but the base is isolated, which is what I was going for. Now here, it's all about that base, so I go ahead and do that. Now, what you do is you type this creature in your calculator. It's either change of base time or it is directly substitute that in there. Now I know what all you're thinking. Could I, in fact, add 9 over or subtract 9 over right now? And the answer is, well, yes. However, you don't want to do that yet without first finding out what the log of 72 divided by 10, I'm going to use log this time because I feel like writing the word log. You want to find out what this particular answer is. Now again, you could use ln if you're so inclined to do so, but you don't have to. But you want to figure out what this is before proceeding further. So, we go ahead and do that. This is 0.71199 and 9, and it goes on a little bit. Here's what I'd say to you. You keep this in your command line of your calculator and just hit answer minus 9, then to subtract 9 from both sides, and you go ahead and go with that. It would be the best option in both worlds. So we go ahead and do that. And your answer here for n equals negative 8.2880. You could always check this, but remember, when I check this in the problem, you're exactly not going to get 72 because this number isn't exact, it is a bit rounded. Moving on. So over here, what do I have to do first to this problem? Well, think PEMDAS in reverse. The first thing I need to be doing is I need to be subtracting or adding that wonderful and glorious 3 over. So I go ahead and add the 3, giving me 10. Then, what do I end up doing? I end up dividing by that 8, because again, the base isn't isolated by itself. Now, I'm not going to get a decimal here. I'm going to leave this as a fraction over here, simply because I can. I'm allowed to do that, and it just makes it easier for computation purposes later. I want to avoid rounding as much as I possibly can. So, when I do my little loop here, that's where I go ahead and I can start to figure some of this stuff out. Now it's all about that base again. Now over here, it's calculator time. Now again, you can change the base it if you like. I'm going to here, let me use log again. Again, ln works just fine. Don't freak out about that. Now, with the change of base formula, remember, I can technically change this base to whatever I want. The reason why I'm using 10 and log base e, which is ln, is the simple matter of, hey, wait a minute, this is what my calculator has available to me. Why would I change the base to like 25 if my calculator can't do 25? If it could do a base 25, I could just put this entire thing in one command line. So, here we go. This is 3, 2, 1, 9, 2, 8, so on and so forth. That's r plus 4. I subtract 4 and get r equal to negative 3.6781. Circle and continue. Okay. This problem. What I have to do first here, I've got to take negative 34 and I got to add 8 to it. Now when I do this, I end up getting negative 26. I then divide by that negative 6. It's got to be the negative 6. Take the negative along with it. I get 26 over 6. Turn that into a log using our loop diagram. Now I'm going to give this 13 over 3. I'm simply going to simplify it down. Equals 4x here. Again, this is doing our little loop diagram here. Now, when I do this, again, change the base time. I'm not going to show that step again. Well, you know what? Since I'm so nice and magnanimous, I'll do it. Thank you, Mr. Faust! No, welcome. Imaginary voice in my head. So when I do this, I'll use ln this time. Because I can. Now, you should know that, again, for like the umpteenth time, does not matter here. I get a number here for that. That number is excuse me, 0.1668397. Divide by 4, and I get x equal to 0.1668. Again, the instructions said around to the 10,000th place. That's why we're doing that. Alright, moving on. Ooh, this problem, a little trickier. Alright, pretty exciting though. So I'm going to again add 3, no big deal. I get negative 1.6 times 9, 8x plus 2 equals a negative 8. I then divide by negative 1.6. Now, again, folks, I am leaving it as the unsimplified version. I'm just taking out the negatives here because I don't want to end up rounding too much in the problem if I don't have to. If I keep doing that over and over and over again, rounding and rounding and rounding and rounding around the mulberry bush, we end up finding a wrong answer, which is not something anybody wants. As the kids say, ain't no one got time for that. So, here, I go ahead and figure this out. So now I do here, again, you could do change of base, or if your calculator has the ability to type that in, go ahead and type it in. But let's go ahead and figure that out.
I believe computers are important.
This is 0.7324868 equals 8x plus 2. Now how do I solve here? Well, I'm going to subtract 2 from both sides.
Because driving matters.
Now, when I subtract 2 from both sides, I end up getting negative 1.26751324. Again, I'm not rounding in the middle. Divide by 8 here, and I get x equal to, this is where I want to round, negative 0.1584. Circle it and be done with it. Again, here I divided by 8 in case you were wondering. Alright, let us continue. Now this problem here, I want to add 9 to both sides first. So let us go ahead and do that. I add 9, I get 3 times 20, 9 minus 7p equals 17. I then divide by 3 and end up getting this. 17 over 3. I then turn it into a wonderful and glorious log, which is what I want to do. Yes, cue the trumpet sounds. And I can do this. Indeed I can. So when I do this, I go ahead and use my change of base formula. Or, if your calculator has the ability, go ahead and don't use change of base formula. The world is your oyster, whatever floats your mathematical boat. So, 5, 7. Now from here, the answer is a foot. Not literally a foot, but it's close. I'm going to subtract 9 and get this. That was subtracting 9 there, folks. And then what I end up doing is dividing by a negative 7. And getting my answer. Now, I get P equal to 1.203. It was 29, folks, but the 29 rounded up to 3. So there you go. You are now prepped and ready for some log problems. Go henceforth and do.